So, what are the dimensions? We did that before, I think. Dimensions are the independent columns. What makes them independent? What's the independentness of the independent columns? They help you to uniquely identify the rows in your data table. Yeah? Such as in this one, there's like country year. And the next one is country, rural, urban is not a dimension year. And then you keep adding the dimensions. And then that's how you slice the data by like finer and finer population groups. Here is only one measure, so the greens are measures. And those are the dependent variables of your data. Those are like things that you learn from this data table. So if this data table, if you encounter this in the wild, it doesn't tell you that Brazil exists. And it doesn't tell you that the years happened. But it does tell you that vaccination rate was in this year and in Brazil so much. And in this year and in Brazil it was so much. Yeah? So the measures, they give you the new information. And the dimensions, they tell you what this information is about. Yeah? So this is like introducing the characters. The dimensions help you to introduce our data points. And the measures are like what we learned about. One test that you can do to tell if a column in your data table is a dimension or a measure is you try to remove it. And then if you do remove it and the table still works, then you've removed the measure. It was a dependent column. We remove a vaccination, we have country year, the table still works, it's useless now, but it still works. And imagine we have like multiple measures in the data table, then it will still work fine. However, if we remove the year, then the table would show Brazil 75%, Brazil 83%. Oh no, now we cannot identify the rows anymore. We have an ambiguous data table. Yeah, so that's how we know we removed that dimension from it. Okay, so I have a couple of examples to go through, and we'll spend the rest of the lecture just looking at the dimensions and measures, because it's the most like central concept of the class, the data visualization in general. So, and we always look at dimensions and measures from two angles. One angle is the visual angle, and the other angle is the data angle. Yeah, we have data, we have visuals, bomb, pineapple pad. Yeah, the visuals is the marks. Yeah, that's the bars or lines or whatever we have on the screen. And the data side is the data tables. And converting data tables to the visual marks is the whole magic of the process. That's the visual mappings. Here I have two population numbers, one for USA, one for Sweden. What can I do with these two numbers? I can show you two bars. Can I show you line chart from this data? No. Can I show you population pyramids from this data? Like age groups and stuff? No, I don't have data for it. I just have two numbers, and these two numbers identified by the dimension here is country. So country, one number, another country, another number. Easy, yeah? All right. Let's start adding dimensions now to this example and see how, like, other charts that we could create once we add the dimensions. What if we add country time? Can you imagine what charts becomes possible if we add a time dimension to it? Now you have population by country and time. You've seen this chart before. Population by country and time. What if we add age? Population by country age. Maybe you've seen those charts before, like from demographics, everything. What if we add age and time? Oh, now it's interesting. What if we add gender, country, age, gender? What if we could add age, gender, time? Now we have country, age, gender, time. Yeah. So the complexity of the chart increases, of course, once you add these dimensions there. But also, like, the number of marks will increase, because here you just show the 2 marks. That's the only thing you can do. In a situation when you add a time to your marks, I'll show you a population here. How can I turn that to a... I'll get rid of size. Okay, one size. Bam. Get rid of size. I change that to population. I only select USA, like we had, and Sweden. And I've removed everything else. And look, I have 2 countries. GDP, I change that to time. Wow, we had very similar population 200 years ago. Didn't know that. And now I can, like, I don't know, I'll add China for like contrast as well, so that we have some more. See, this chart becomes possible when I add a dimension of time. See, every dot here is country and year, so country time. What?
Oh, nothing. It's just it's crazy that the Swedish population's like kind of flat the whole time. That's all I was.
From far away, it looks like
Yeah,
this.
from far away.
Yeah, this will go down now. See, China has peaked population. Now it's shrinkage is happening. But this is country time. Now you have like 1 data point per country time. Yeah, amazing. Look where it goes. Let's add age groups. So we have USA, and we do China for contrast. You see, they have very different like size of population. That's why they have different size of the area here. But I have a percent button. That's where I can like show them comparatively, so that they're roughly equal size. H bar is now. Can you name the dimensionality of every bar here? Of the marks? Yeah, bars are marks. What does every bar show?
The percentage of the population that is a given age.
For a given age, 1 dimension. More?
The
Country, 2nd dimension. 2-dimensional, there's 1 more. Year, yeah, see? Country, year, time. So now it's a 3-dimensional chart and 3-dimensional data table. All right? You're good here. How about we add a gender? What happens? You may have seen these graphs before. They call population pyramids for a reason. What if we add a gender? Yeah, we have 2 sides, male and female. Yeah, I have a button here, 2 sides. Then it looks like this. So there is like male and female side. And this is the... so now what each bar represents. Quickly, please answer.
Age, gender, year, and country.
Yeah. So a population in age, gender, year, country, 4-dimensional.
Why is it darker on the edges?
Hey, it's just a visual trick that I did. Well, strictly speaking, it's a separate mark, but it's I cheat here a little bit because it's a mark that is linearly dependent on everything else. It's a surplus because there is more boys that's being born usually in a population, And then by the age of like 50, 60, like we do more stupid shit, so we die earlier. And then there's like more women left in the population in the old age, and women live longer. And this darker color just shows the surplus of the population comparing to like which side is longer, so that it's visually easier to see. It's a good question because in a healthy country like United States, even though I know there's problems with healthcare and everything, but it's a country with democracy and functioning institutions. If I add some other country, which you may have heard of, which doesn't have like functioning institutions, that change will happen. It will be more pronounced, and it will happen earlier. Like at 40 years already, there is this imbalance that goes to the other side. So the life expectancy of men in Russia is a lot lower than life expectancy of women, and that's like a big problem. Right. 4-dimensional chart. Cool. And then I have just a slide that shows that this is possible. Are we good on this? Do we need like a mental break for like a minute or so? We fine? Everything's fine? The next part is heavier. Okay. Let's look back at this bubble graph again. And for this exercise, I have prepared one of my data variables here. Literacy rate adults. It's special, you'll see why it's special. So here, again, like every bubble here shows a certain country in a certain year. So that's two-dimensional what chart? Two-dimensional data table. Yeah. So the tricky part is, and this is time. Yeah. So I'm just hiding the bubbles that are not visible for the year that is not shown at the chart, but like I can do this, select all in Asia, select all in Africa, select all in America, select all in Europe. Now I have too many labels, don't like that, so I'll remove my labels. And if I do this now, see, now you see that the chart has actually like one mark per country per year. Yeah. So what do you think about the color in this chart? What does color depend on? Color is one of the encodings, right? So what's it depending on?
Continent.
Yeah, and continent in the data, what does it depend on? Like every data is like by data points are country type. How about the color? It's not changing over time, right? It's still the same, like all over the place. I can change it to something else. I don't know. Let's press GDP per capita, so that we have different colors, and they are the same as x-axis now, so that you see the colors are changing as well. So now the colors are changing with time, but normally they don't change with time. So how would that be reflected in our data tables if we have colors that show us the world region like that, and they don't change over time? I guess this is the point where I involve this whiteboard. I have the bubbles there. And the bubbles, they are now showing me country time. So each bubble is a country time data point. So bubbles are two-dimensional. let's look at the color here. What do I want from you? I want you to tell me which columns would exist in the color data table. Because you see, this has no, these are just like the marks. We just defined the circles. We don't even know where to position them yet. We don't know how to color them yet. We don't know what the size they will be. Yeah? We just named the circles. What about the color? Tell me. Help me solve the mystery.
Country and color
Yeah?
is
Before we match that to our visual encodings, it would say something like a region. Yeah? And then country would be like China, and the region would be like Asia. And then the country would be like Sweden, and the region would be like Europe. What's the dimensionality of this table? Why?
The country and region. I think that's one,
Why?
because you have one independent variable and then one dimension.
And one depends on it. Yeah. What's the dimensionality of this one?
One.
Why one?
I think. Actually, no.
Try remove a column. What happens? You remove this.
Yeah.
You have China, India, Sweden. China, India, Sweden.
Yeah, I think so too.
The table become redundant. That means it was a dimension. Try remove country. Now you have 2010, 2010, 2010. It become redundant again. That means both of them were dimensions. Yeah? So it's useless. So far, we just defined our circles. It's useless, but it is two-dimensional. This is two-dimensional, this is one-dimensional. Do you know the operation to smash the two tables together? How is it technically called?
Join.
Yes. And specifically, there is left join, there is inner join, there is outer join. Let's use left join. Let's use this as a base table. And let's put this one in here. Yeah? Let's join this to that. So I have a result. I'll make a section here to show the result of our join operation. Our join would look like, and please help me write this because I want you to participate in the writing. What columns do I put here?
Country.
Country. And time. And then
region.
region. Yeah. So for my China, and I'll write it like this. I'll sort it now by country to illustrate the point. (2010, 15, 2020). Yeah? What's the region here?
Asia.
Yeah? The other year?
Asia.
Hey, it didn't change. And didn't change again, Asia. So this thing repeats in our data table. So this is what happens when you join a lower dimensionality data table with a higher dimensionality data table. Yeah? We had country time here, and we had country here. So when we join this one to this one, we don't have time, so we need to add a time column for them to join. And we can only add the time column by repeating these values in the region for all the time points. And this is the result. Yeah. Now we can put that in the chart, and now our bubbles have colors. Okay? Easy. Now let's go around the y, x, and size encodings and quickly sketch the same tables for that as well. And this is easier. We just started with the hardest one, but please go with y first. Name the columns. Please.
Region.
So y is the literacy rate data that we have. Does it depend on region? Or like, is the region involved in there? No. Y is the position of the bubbles, yeah? So what does it depend on?
Literacy rate.
Is that a dimension or a measure? A measure, yeah? Yes? Well, you did name a column. So literacy rate here. What more?
Year, time.
Yeah, time, exactly. Do you see how joining that is easy? You have your country time here, you have your country time there. This is just a task of finding the same key in country time here and like having the number, because you have the numbers in this table, and then you put them here. Yeah, so literacy rate over there, which will depend on country time, and we'll have different numbers for, well, this was China, so it's like, yeah. I removed the labels, but you get the point. This is China, and it has different literacy rate for different years. And then there's like other countries. I don't even like know which ones are which anymore because I've selected all of them. Let's get back to labels. Not Yemen. Oh, that was India. Where is China? China here. And maybe some other country, Brazil, some other color. So different. Different literacy rate for different years, for different countries. Yeah, easy. Or so far it's easy. X.
GDP per capita.
That's one of the columns. Do we have more columns in that data table?
Country and time.
Yeah, you're getting it. And if we join this table with this table, it's again the same situation, right? So there's like nothing weird here. So this provides us a key which we can use to find a value with the same key in here, and we can put it in this table. So GDP is successfully joined to this table now as well. And what about size?
Country, time, population.
And when we join it, same thing, yeah? Nothing strange. Okay, so we see the graph and we see the data tables. It's the same information represented different ways. Our activity here in doing visual mappings is to convert these data tables into graphs, yeah? So these are a language of the data tables, and this is the visual language of the graphs. This is how one transforms into the other. I will now give you some exercises, and you'll try to like reverse engineer what would the data tables look like for different situations in the graph. First of all, I change my color to, well, we've done changing it to GDP already. So that was, we've done that already. But what about if we change it to a single color and now everything just becomes orange? How would the color table change in this example?
Would it like disappear?
Almost completely. Because it's still orange color, right? You still have to have orange somewhere. So in this case, would it depend on country? No, not anymore. So we remove this column. And then our region, it's not Asia or Europe anymore. Yeah, there's no distinction between Asia, Europe, whatever. This is our entire data table for region. Done. Orange. That's the data table we need here. And what if we merge it in here? Like instead of the region, that is Asia, 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 what will we have in this data table?
Just orange.
Just orange. For all the way down. So it's orange. So we used to merge one-dimensional table with two-dimensional table. What is now the dimensionality of this one? Ivan?
0?
Yes, exactly. Now it's like 15 minutes before 1. Do you need to go now?
Oh, I can say it.
You stay. Okay, good. Yes, correct. Zero-dimensional. This thing merged with this thing results in a repeating of your constant value over the entire table. And that's the only case where you have the constants, yeah? Zero-dimensional situations. If it's two-dimensional, it's easy, yeah? If it's one-dimensional, it's on. Okay, next exercise. Let's do 2 more exercises quickly. I now change my literacy rate here. Come on, literacy rate. I have 2 options here, by country time and by gender country time. So I add a dimension here to literacy. Let's erase gender. So country, gender, time, literacy. How would I now merge this table with this one, given that it has a 1 extra dimension? I'll spell it out a bit. So China. Time would be, well, let's say 2010, 2015. Yeah, male, female. Yeah. So the table kind of explodes in the size as you add these dimension columns. And then there's like a literacy rate value for each of them. So if I want to bring this data here, what must I do? This is still country time. If I just remove this column, this becomes ambiguous because I have 2 values for each of them data points. So that's not possible. What should I do? Okay. It's only 10 minutes left, so I have to like speed up through this, but we can filter it. Yeah? That's like, we have two options essentially. We can aggregate our male and female in some sort of formula. In this case, we'll need to do like a weighted average and weight them by population, and then we can bring them together. But in that case, we're ending up again with country time literacy, yeah? So if we aggregate each of them together, that's not helpful because we just end up having this again. What else can we do? I said filter. How do we do that? That dimension that is sticking out of the space that we need to project anything towards, this is also like called projection of higher space or like higher dimension to a lower dimension. Like you have a cube, you project it to a plane, and what you see on the plane is like a shadow of a cube, yeah? And then only like one dimension of the cube will be visible. So you'll need to fix that to like, not male, but M. So one of the options. So you fix it to M. That will allow you to filter this data table such that you remove every other row from it. Then this becomes redundant. You just have M all over the place. Then you can remove that column. And now you have country time literacy male. And now you've successfully projected it here. Now you can join the two tables. Yeah? You're still with me? That was good? So here I can fix that to male, apply. And it looks weird with this constant color, so I can bring it back to world regions. So literacy rate male on y-axis. This is what we have now. Let's do the same thing for X. So, but instead of GDP, let's do also gender. And then we take, again, literacy, education, literacy rate, adults. Oh, by the way, before I move to the final state, look what you can have here. You can have literacy rate male on the Y and literacy rate total on the X from that previous data table. That is not split by gender. But we fix the gender this time to female, to F. That would result in the same situation, but we remove the other rows from the same data table. And then we can again join them together, and then the result will be literacy male. Instead of GDP, which should be X here, it should say X. Yeah? We have literacy female. And I did revert it back to Asia, so. So now you have different values, male, female, here, as columns. Yeah? So you've gotten from like a higher dimensional table with rows to a lower dimensional table with two columns, with double less columns. And you put one column in Y and another column in X. Practically, in the chart, it would look like, I have an interesting story here from this chart, because now I have, bless you, now I have countries that in 2010 had like a lot higher tilt towards male literacy, and I have only one country that has a higher tilt towards female literacy. So this like the further they go from diagonal, the more, you know, this is the difference of the literacy rate between male and female. To the male So most countries, especially like the poor ones, Bangladesh is here, Yemen is there, they skew towards the male literacy being higher than female literacy. Do you know what country, the only country that has higher female literacy, or women have more literacy than men? That tiny green bubble there. Yeah, Bomboklad. That's the one. So here we've joined tables with higher dimensionality onto the tables with lower dimensionality. All good, yeah? So that was this exercise. And now before you go, there's a final exercise I'll show you. If your mind is not blown yet. I want to add a column here for the marks. I want to add a gender column here. So now China, India, Sweden, they would be like male, male, male. 2015 will be male, male, male. And then like same thing again, female, female, female. So female, female. So how would the chart change when we add a dimension into the marks? Remember that this identifies our marks, and the marks are bubbles.
Would each mark become like a pie chart?
Yeah, possibly. But then your mark is not a pie chart, and a pie chart is now a visual structure. Your mark would be a section of the pie chart. Yeah?
Oh, yeah.
So you would have, but let's stay with bubbles. Yeah, you can have sections of pie charts. Well, first you have more rows of that table, isn't it? So you should have more bubbles. What would each bubble be? Remember how we split the pyramid with male and female, two sides? Same thing here. Yeah? Please give an answer. I'll rather do it and then you tell me what I did. I sliced marks by gender. Yeah, done. And I find my Bangladesh again. Do you see what happened? See why? We have now double the number of bubbles because now each bubble represents male or female. Yeah, and they are changing over time. Yeah, so you could see like Bangladesh 2007 female and then Bangladesh 2007 male. Yeah, so you would have instead of this thing now. Oh, there was an easier way to do that, but let's just spell it out again. Gender. So, and I make it a bit easier for myself. I do like 2010, male, female, 2015, 2015, male and female, yeah. China, and so on, and so on, and so on. So, let's look at the projection of the encodings that will happen here. And we can start with color again, because it's easy. Color is, again, only depends on country. Yeah? So color, which is our region. Can you help me?
They're all Asia still.
All Asia still, yeah. And for Brazil it will be Americas, and for Sweden it will be Europe, and so on. So it's a one-dimensional table joined onto a three-dimensional mark table. Yeah, and that results in values repeating for every dimension which is not present in this table. Okay? Size. What about size? It used to be the same dimensionality as the marks table. Now it's one dimension lower than the marks table, and it's now the same situation as with color. So what should I do here? Come on, there's two final bits in here. There's one of them, two final bits. What will happen to this table here? How's it? Do you know? Do you know?
Can you restate what you're asking?
I'm asking how to join a two-dimensional size table or population table, two-dimensional population table, with a three-dimensional table here with country, time, gender.
You joined by country and time.
Yes. What do I have with gender? I don't have it here.
Oh, I see.
I don't have a gender here, so I have to repeat my population for male and female, which is wrong. This is when you see this chart on the Twitter, or you see a chart like this in the research paper, and then you check and you have your China population, 1.34 billion in this bubble and 1.34 billion in that bubble. So both male and female, you end up with 1.34 billion. Is that correct? No, this is bullshit. That's what your citizens' obligation to do is to call bullshit on a chart like this. So population is now 1.3 billion, 1.3 billion, 1.3 billion. For no, it will change on the year, of course, but it will be same for two different genders, which is incorrect. There's one final bit, and then I'll let you go. The final bit is what happens with X and Y table which had literacy in them. Remember previously, to join a lower dimensional table, no, a higher dimensional table to a lower dimensional mark, we had to fix gender, we had to filter it to male here and female there. What should we do now?
Combine them into the same column.
But we have X here, we have Y here. Then they both show literacy. And you have answer on the chart if you prefer the language of the visuals. So what happens here? Remember, we only needed the filter because our gender was not in this table already. So we had to project the gender to a lower dimensionality. We had to choose one, yeah? We don't need to do that anymore. Because now this dimensionality of this table is the same as dimensionality of that table. Yeah? You with me? This is not needed. This is not needed. So you have all the rows again now. In this table. Yeah? All the rows of literacy here by country, time, gender. All the rows of literacy here by country, time, gender. They would it would be easy to find Sweden 2015 male in this table and in that table because you have the same key for both of the tables. So you can just have them joined easily. Just like that, without any filtering. However, since this is literacy and that is literacy, you would have the same value here and there, isn't it? So for China 2010 male, Asia, or China 2010 male, you have X equal Y, isn't it? Do you see how it's visible on the chart? They're all on the same diagonal. And no matter if I do it with, I scroll it over time, They're still in the same diagonal. This is all. Thank you for today.